Hi everyone, Niall here. Welcome back to the 8020 BIM channel. Today I'm going to talk about how you can quickly and accurately model your structural roof purlins and your structural elevation cladding rails in Revit using beam systems, which is my preferred method, as well as a couple of manual edits where necessary in order to make sure the alignments of all your members are correct. So without further ado, we're going to go and create what we have in this view in front of us here. From an empty portal frame model. So stay tuned and we'll get started. So to begin modelling our purlins and cladding rails in Revit, we first have to introduce the light gauge steel members into our portal frame file that we have open here. So in order to do this, what we want to do is go to the Insert tab, Load Family, and then I'm using the UK metric. You might be using US metric, US imperial. You may be using a different source library, but in the UK metric specifically, you can scroll down to your structural framing, and then you'll see that we have a light gauge steel option. And here we have the Kingspan multi-beam purlins and the Kingspan multi-beam rails as standard. So I'm going to introduce one of each of these variants. So I'm going to open the multi-beam purlins first, and I'm going to scroll down and I want M205's 150s. So I've introduced that purlin member now, and similarly I want to load family again. I'm going to go down to our structural framing, light gauge steel. I'm going to scroll down to our multi-beam rails for the cladding rails, and I'm going to find the same member variant 205.065 150 and press OK. So now I've introduced both of those beam member families into the project. Now the reason I say beam member families is because using structural framing normally refers to a beam, and the structural column families refer to columns. And the way we're going to approach modeling the purlins specifically is to use a beam system so that we can place them en masse across various roof planes that we've created. So that is in fact the next step. So the first thing we're going to do is, if I go to the ground floor plan just to give you a bit of an overview, you can see that we have a north, south, east and west elevation already set up. So I'm going to go to the south elevation here, and you'll see that we have ground level, eaves level and ridge level already defined. So what I want to do here is I want to place a structural plane, a reference plane essentially, on the fall of each side of the roof so that we can host our beam system to that fall. So if I go into the structure tab, on the right hand side you're going to see work plane, okay, and I'm going to set reference plane. The shortcut key for that is also RP. So you can press RP. Now, I'm going to pick a line, and I can actually select the top of that member. If I want, I can give it an offset. So in this instance, I'm actually going to give it an offset of 10 mil, and that just allows a cleat build-up for our purlins, okay? So now you can see that we're applying a 10 mil offset once we select that plane, okay? And we've introduced a new reference plane to that fall. So because I'm in the south elevation, I'm going to call that westward roof fall. I'm just going to extend it out a little bit there on either side. And again, I still have the select pick line option selected in the reference plane. So I can go to the opposite side, the opposing side, and click. I'm going to drag its extents out a little bit just to overlap the members, and I'm going to call that our eastward roof fall. Sorry, apologies. So now we've created our reference planes for the roof purlins to be hosted to. While I'm also in this view, I want to apply a reference plane again to our elevations. So we can apply a reference plane to our west elevation and our east elevation. So I'm going to do that now. I'm going to select the outermost side of our largest column member, and I still have the 10 mil offset to allow for a cleated build-up, and I'm going to click that, and I'm just going to call that west wall for reference. And then on the reverse side, again, select, and I'm going to call that east wall. So now we've set our reference planes for the majority of the model with the exception of the either end of our portal frame. So when I go into 3D Space, I can show the reference plane that I'm actively working on now, okay? But what we want to do is we want to set our reference plane to match one of the reference planes we've already set up. So in that instance, I'm going to press set, and it's going to bring up this dialog window here for the work plane. So we can assign a level, which you're seeing now at the moment is the ground floor level, but I also want to pick a plane, okay? And I'm going to press OK. Now, the difficulty is that I'm not actually in the view where I can see the reference planes active. So if I go back to our south elevation, I go set, pick a plane, I can now select our plane that we wished to use. And then I'm going to just go back to a 3D view, okay? And now you can see, if I go to the edge, that we have a plane that's following the roof falls on the westward side. So now that we have that, I know this comes off at a weird angle, but it's just something that Revit does in the 3D view. I don't understand it myself. But now that we've set our reference plane to follow the fall of the roof of the portal frame itself, we can begin to actually place our purlins. So in order to do this, we want to go to our structural tab, and we're going to use a beam system. We could use a beam if we wished and place them one at a time if you have an uneven interval that you'd like to maintain. So let's say you might have a 600 offset and then a 900 and then a 1200. You may wish to forego the beam system and just place them manually. But in this instance, we're going to use the beam system. So by selecting the beam system, it brings up the usual placement options that we have, okay? But you will see that we have a layout rule on the left-hand side in the properties, and we can give it a fixed spacing as well as a justification, and we can select our beam type. So because we're at the roof level, we want to select our multi-beam purlins, the M205, 065, 150s. And then we're going to set our fixed spacing, in this instance, to 1200mm centers. We could change that rule if we wished. We could give a fixed number or a maximum spacing or a clear spacing. But in this instance, and the majority of instances, to be fair, you're probably going to use a fixed distance similar to this. For the justification, I'm going to leave that center for the moment. And as we've already selected our multi-beam as the member. So I'm going to snap to a top-down view of our grid now. I'm just going to turn off shadows temporarily. And I'm going to draw our beam system to follow the footprint of the roof. You'll notice that when I was trying to use the rectangle tool, it was actually following the direction of the shape of the reference plane, which wasn't functionally correct. So we're just going to draw it in manually as I'm doing here. We're going to snap to our endpoints as such. And we're going to continue down. Now, you'll see that we have these 3 lines here. And that 3 lines indicates the directions that our beam system are going to lay our members. So if we left our 3 lines on this small perimeter edge here, what we'd end up doing is having the 1200mm repeat our members in this direction. So we'd end up following the cursor there, we'd end up with our purlins going in the wrong direction. So what we want to do is we want to select beam direction and we want to select the lawn boundary. And now we're going to have our beams move north-south all the way along. Okay. So I'm going to finish that there. And as you can see, we've placed a number of members already. When I scroll down, I'm going to turn off the showing the reference of the plane. You'll notice that we actually have them within the depth of our roof. Now that's not what we want. We want them to sit proud of the roof. So what we can do in this instance is we can select all instances, visible in view, and you'll notice that they're actually not in the correct orientation. These should be facing up into the falls of the roof. So I'm actually going to change the cross-sectional rotation to 180. And you'll see now that they've actually snapped to be placed above our roof fall correctly. So we actually have our beam system fully modeled with each of our purlins placed. Now, just to show you how our justification works, we can change the justification of our members from center to beginning. So if I press beginning, you'll see you can't keep elements joined, that's fine. And you'll notice how we had a shift in a few of our members and we've actually lost this initial one. That's because we actually began our boundary down the center line of the roof. So it's moved the placement to the edge of that center line. So that's what it means by beginning. Again, we can go to end and you'll see we've introduced a member at the end, but we've lost it at the top because our roof doesn't fit an exact 1200mm increment. Finally, we can go center or we can pick direction line. Direction line can be a bit confused because you actually have to assign the direction line within the edit boundary tool of the beam system. The majority of the times you're going to use your center. Okay, and as you can see with the center, we have our members placed universally throughout, but because we've introduced a new member, we've lost its rotation that we've given the previous members. So we have to go 180 in the cross section again, and there we have our first line of roof purlins placed. The way to follow to create the opposite side, because we haven't placed these individually of one another, we can't actually select the whole beam system and rotate it or mirror it, because if we mirrored it down the axis, it'll still follow our previously assigned reference plane. So when I mirror it down the axis, although it looks correct in plan, when I go to elevation, you're going to see it's still continuing down the reference plane that we've set. So if we set edit work plane, we can go back to our south elevation. I'm going to select that beam system and we can edit the work plane. We can then pick a plane and snap. But as you can see, it's not actually changing, and the reason for it is it's locked to our plane. Okay? So what is intuitively correct for us is not necessarily going to work for the program. We cannot just reassign this as a new plane. We can pick new plane as such. Pick a plane. And now we can go to our 3D view. But as you can see, we still have to place it in a very kind of rudimentary way. It doesn't function the way you might imagine it to. So you can't really mirror our beam systems on the roof level. So there's two workarounds for this. One is to abandon the beam system. So we could actually select each of these members independently. Apologies. I could right click and select all instances to pick these, but as they're the only members of their type in the project. But if we introduced other members of the same type in the project, then we'd have difficulties just isolating the ones. So in order to mirror onto the work plane over here on the eastern side of the building, we can select each member independently of the beam system, and then we can mirror it down to center point. We can delete our elements, but there's another problem here. You can see that it won't actually allow us to separate the members from the beam system in order to mirror them. So we'd first have to unpin them from the beam system, meaning that we lose any of the potential edits that we can apply after the fact. So for example, we have a fixed spacing of 1200mm, but if during the project timeline that reduced down to 1000, we can merely press 1000 and you'll see that the increments changed. If we had disassociated by unpinning the members from our beam system, then we wouldn't be able to make that edit as quick. We'd have to manually replace each member. So quite simply, the most straightforward way of taking this arrangement and applying it to the other side of the roof is to actually go through the system, creating a beam system on this work plane. So yet again, we go to our south view. We're going to set a new work plane. We're going to pick a plane. Okay, we're going to pick our east roof fall. We're going to open again in our 3D view, open view. We're going to snap to our top view and we're going to place our beam system. We already have our purlin selected. We already have our fixed distance and our justification of center. And we're just going to draw the same boundary on the opposite side of the roof. So I'm going to go to the midpoint here. And you can see that I'm actually drawing it as the mirror image as well, so that the orientation of our members mirror that of the orientation of the other members. And you'll understand what I mean by that statement now in a second. Now, again, we need to make sure that our beam direction is going north-south and not east-west. So we're going to set our beam direction to the boundary there, and we're going to finish that. Now, again, you can see that we have our members placed in the depth of our roof, which is not what we want. So I'm going to select all instances, visible in view. You're going to see that we're going to select both sides of the roof, but I'm actually just going to group deselect this side just to make the selection a little bit easier. And again, we're going to set our cross section to 180, and they'll snap up. Now, you will see that there is a bit of an issue because we drafted in, when replacing the beam system, you will notice that you can draw the beam system boundary in a clockwise or an anti-clockwise manner. And that actually dictates the orientation of the members within the beam system, and that's something that people don't actually understand. So in this instance, we actually have to rotate our members entirely. So the solution here is not actually to use the cross section rotated. We actually want to put that back down to 0. And you'll see that they're the mirror image as I described what they would be. But what we're going to actually do is we're going to give them a Z justification of bottom. And they will snap up to the same placement. And as you can see, we have an exact mirror image on both sides with the 10mm offset to allow for the cleat build up at the back of the members. And we've now finalized our roof purlins placement. So that is my recommended method of placing roof purlins within the Revit project. The way to place cladding rails on the elevations works in much the same manner. So you understand that on our south elevation, we've introduced our door frame here. On the west, sorry, apologies. On the south elevation, we also introduced our wall reference planes that we want to use as the base for our cladding rails. So we're going to go through the same process again. We're going to go to beam system. We're going to go to, sorry, apologies. We're going to go through a 3D view. And we want to set our work plane. So we're going to pick a plane. We're going to go back to our south view. I'm going to select set work plane, pick plane, select our elevation. We're going to go to elevation east and we're going to open. And now we've opened our east elevation. Okay, we can see quite far back in this. We're actually seeing we're seeing both the east and the west elevation. That's why we're getting a variance in the bracing here. So what I'm actually going to do is I'm going to set clip without line, and I'm going to set that distance so that we're only seeing the front elevation. Okay, might have to go a little bit further. Now, you can see we're not getting the duplicate from the opposite side of the building. Okay, so now that we're on our east elevation, we can go ahead and draw our beam system much the same way as we did previously. We can create our boundary line. So in this instance, we can merely draw it as a rectangle because we are in an elevation view, we're not in a 3D space view. Yet again, we can set our beam direction. So if we wanted them to repeat vertically, we can do that. But in this instance, we obviously want them to go horizontally. We're going to set our fixed spacing on the elevation to 900. We're going to use the center justification, and we're going to change our beam type for our beam system to our multi-beam rails. So we have a distinction between the roof purlins and the cladding rails. And we're going to finish. And yet again, you can see that we have the placement. But when we go to 3D view, you'll notice there's a few issues. So first and foremost, they have placed in the wrong orientation. And this is a standard orientation that they will play out. Both the cladding rail families and the purlin families will automatically place with this vertical orientation, and that's because this is the strong axis for placement. But in reality, we actually want our strong axis to work horizontally for the wind loading so that our panels can be mounted onto our cladding rails. So what I'm going to do, because this is the only section where these have been placed throughout the file, I'm going to right click, select all instances, visible in view, and I'm going to change the cross section. And I'm going to change that cross section to 90 degrees, and we're going to see how, oh, apologies, I don't know what happened there. Right click, select all instances, visible in view. I'm going to change the cross section to 90 degrees. And I have a feeling this is going to go in the incorrect orientation, which I was correct. So I can then type in -90, or in this instance 270. It's the same value. I'm going to press enter, and you'll see that we've rotated around in the correct orientation. But the problem is we're still going through the depth of the primaries, where it has to stand proud of the primaries. So in this instance, because we've rotated it through 90, we actually have to change our Y justification from origin to left. And you'll see now, if I snap to the end, that we are now standing 10 mil proud of our primary member, because that is where we set our reference plane from. And that means that our Y justification has been set from this point across, and we're using the leftmost side of the member, which you can understand now. Okay. So what's good about beam systems being used for cladding rails on something like this is that we can actually mirror these. So I can select the grid line there, and we will get our members mirrored to the opposite side. But as you can see, because we flipped to the opposite side, our orientation is incorrect for those particular members. So I'm just going to click and drag over this. I'm going to deselect the beam system itself, and I'm going to change the cross section to 90. We have yet again lost our members. They've gone into the depth of the structure, and that's because our Y justification is still set to the left. But now, as we understand, looking at it, we need them to be offset from their right hand side out the way. So I'm going to right click, select previous, which is all the previous members I had selected, and I'm going to set the Y justification to right, and that will snap out to yet again 10 mil off of the face of the largest column on that elevation. So now we've placed our purlins on the roof level, and we've placed our cladding rails on the elevations. There is another way to select the face that we want to place our cladding rails in, and the way we can do that without using reference planes is to actually select one of the faces of the largest member. So this here is our most protruding column on the end elevation here on our gable end. Okay, so I want to select a beam system, and I'm actually going to set a plane by picking a plane, and I'm going to pick the end of the flange here. Okay, and when I select that, I've actually created a false work plane as such that represents that face being extended out across the full face here. I can then snap to the end, and I can draw our new boundary. Okay, so I'm actually going to go to the south elevation in order to do this. I want to take the boundary from approximately the edge here. We can neaten this up after the fact to this edge, and then I'm going to go up to here to the intersection back down to here, and then I'm going to close it. Now, we have to be careful here. We could incorrectly set our beam direction here, and what we'd end up doing is having it array as the fall, so we'd end up with our members moving at a diagonal. So make sure that your beam direction is set on your ground floor plane when you're using the gable ends. Yet again, we're going to use the fixed distance, the light gauge steel multi-beam rails, and we're going to finish. And again, you can see the placement goes a little bit awry because we're working on the elevation. It'll always place our members in the strawn axis. So I'm going to right click, select all, select all instances, visible in view, and then I'm going to deselect the boundary ones on the west and east elevation, so I'm just left with that south, and I'm going to start tinkering with these settings here again so that we can correctly orientate our members. So I'm going to say 90 degrees. And I'm going to say our Y justification is going to be left. And again, you can see now we've placed our purlins correctly, our cladding rails correctly. What you would notice is because the increment of because we're using a greater height on the gable end than we were on our elevations, we can't actually immediately align our members so that this cladding rail on our west elevation matches the elevation of the cladding rail on our east elevation. So we can, again, we can go down and we can look at our orientation, cross section, all of those things are fine because we're selected the members, but when I select the beam system itself, I'm going to try change the justification to beginning. Okay. I'm going to change it to end. No. And direction line is not going to make any odds. So what we need to do here is we actually need to change. We can't match the exact set out of the boundary that we might anticipate we could. What I do in this instance, because the beam system is only a notional boundary for placing these things, I merely select our members, one of our members, as the point that we move the whole beam system down. And I'm going to move it into alignment with our west elevation there, and now you can see that we have them perfectly aligned at the corner. And that means I can select that whole beam system. I can edit the boundary. I'm not sure if this is going to work now, so this is a test run. I'm going to move this up. I'm going to press OK, and you'll see we're actually after moving them off center again. So that's not the solution. Okay. I'm going to edit. I'm going to stop editing that, and okay, we're going to leave it as that then. Okay. So what we might need to do in this instance is just unpin our members and then extend them so they have a greater purchase on either end, and maybe we just add one manual member above to close out. Okay. So selecting our gable end cladding rails again, we're going to go to our ridge level, and I am going to mirror these, but as you can see we don't actually have a mirror point that is suitable because we don't have a grid line here. So I'm actually going to go to eaves level, and I'm going to select one of the beams, eave beams, as the midpoint because I know that's the midpoint of the model, and again we have mirrored them to the opposite side of the building. So when we come around, we have our cladding rails complete on this side. Again, you can see that our orientation is incorrect. Okay, so because I've manually edited that one on the previous and it was unpinned, it's not following the same rule set, and you can see that our orientation here is incorrect. So I'm going to just go to the right hand side. I'm going to click and drag to select our members, and I'm going to start changing their orientation. So I'm going to set this to right, and I'm going to change the cross section rotation to 180. I'm going to send that to 270. You can see now that we're in alignment with our other members, but this member here is not following the same protocol, and the reason for it is that was manually changed in its own right. So I'm going to go 180. No, that's incorrect. So I'm going to set that to 0. And now we've finalized the last of our placement of our cladding rails throughout. So now you can see that we have our roof purlins fully modelled and our boundary cladding rails fully modelled, so that we can now start putting in our architectural panels above it. Maybe we need to put in top hats, maybe we can fix directly to our cladding rails. It doesn't really matter. There is one final thing I want to go through with you on this, and that is, as you could see when I unpinned the member up here, it no longer followed the rules of the beam systems. But in this instance, we actually have an OPE, so we need to introduce an OPE into our beam system. But what you'll find once we do that, so I'm just going to tab until I select that beam system. I'm going to snap to the right hand side, and I'm going to edit the boundary. And I'm going to draw a boundary using the rectangle tool. That goes across the door rope. Okay, I'm then going to split this end, and I'm going to trim so that we have this 3D opening available. This is to allow for our rapid roller into our warehouse to function. Okay, so you'll notice, keep a careful eye on either side of this door rope. These members above the door rope won't change their orientation, but on either side, one set of members will lose the association to the beam system rules and will have to be re-edited after introducing the ope. So when I press OK, you'll see that actually, in fact, both sets have rotated into a manner that we didn't want. So looking at this, we have this rotated at 270 with our Y justification set to left. Excuse me. So down here, we're going to select our members. We're going to set our Y justification to left, apologies. And we're going to set our rotation to 270. And now we've introduced our ope and have our cladding rails correctly orientated. So guys, that's a list of my preferred steps essentially on how to approach and model purlins and cladding rails in your structural models in Revit. If you have any queries on this or have any other suggestions, please let me know. I typically use this for the larger faces, as you can see now, and what I might do is I might normally use the center alignment for the spacings and then add a manual purlin or cladding rail to, let's say, the purlin at eaves level and at ridge level, so I can clearly define the setting out of the start and end points, and then I'll have the even increment between them. Another thing worth noting is you normally will need a manual placement for your eaves if you're using a gutter system that is behind a parapet, because your final member just before the eaves will actually have to be recessed to allow for the gutter detail behind the parapet. Other than that, any comments, questions, or anything you'd like answered, please leave it in the comment section below. I'm happy to help. Like, comment, and subscribe as ever, and I will see you next time around. Take care, everyone. Bye bye.